Hi guys, welcome back to my channel Pirai Academy. In this series of Turing interview question, today we are going to see about a question called longest alternating subsequence in binary array. Okay, so they will be given an array that consists of only zeros and ones. We want to tell them what is the longest alternating subsequence in that array. Okay, what is meant by alternating? Alternating means it will be 0, then 1, then again 0, then again it will be 1, or else it can be 1 0 or 1 or 0, like that. It will be alternating in nature. Okay, fine. Now what is meant by subsequence? So subsequence means, if take for example it is 1 2 3, okay, then I can tell you that these are all the possible subsequence we can form. So what is meant by subsequence? Definition will be, subsequence is a part of the main string, or it is a subset of the main string, where it can be a contiguous or it may not be the contiguous, but it should be in order, which means, see here 1 and 2, this can be 1 and 2 can be a subsequence, whereas 1 and 3 can be a subsequence. While 1 and 3 are subsequence, this 2 is eliminated, right? But it is also okay, this 1 and 3 is a subsequence, okay, because it need not to be a contiguous. But 3 comma 1 or 3 comma 2 or 2 comma 1, these are all not a subsequence because they are not in order. Hope you understand what is meant by subsequence. Now you can understand what is meant by longest alternating subsequence. Let us get into the example. So this is the first example. If this is the binary array they have given, then what is my output? My output will be 4. Why? Because I can take this 1 and then I can take either this 0 or this 0, then 1, then again 0. Okay, then what is my result? It will be 4. Fine. Okay, now see this second example. In the second example, I can tell you that for this array, my output will be 6, because I can take either this 0 or this 0. Okay, then I'll be taking this 1, then again I can either take one of these zeros, then take this 1, again take this 0, and then take this 1. Can you understand this? So my output will be of 6. Fine. So what is the logic behind this? What is the logic behind this? So the basic logic or basic brute force approach, what is a brute force approach is, just to generate all possible subsequence, okay, and check for whether that subsequence is alternating, okay, and among those alternating subsequence, take the longest. That's it. So these are the 3 steps that are required to just make sure the longest possible subsequence in the binary array, okay. But the time complexity will be over 2 power n, because in our subsequence method we will be either take it or not take it. If you don't know about this subsequence, just go and watch my video called subset, okay, subset question. I have solved it in 3 different approaches. I will be giving the link in the description. Just go and watch it so that you can have a basic understanding on how to generate all possible subsequence using a backtracking and recursion. That's why my time complexity is 2 power n, and then my space complexity will be of over n because of the recursion stack, okay. But we can also just make sure here we can use a combination or a backtracking approach. We can also use another backtracking approach, like see here it is 1 comma 0 comma 1 comma 0 0 and then 1. It is like this, okay. Initially I am standing at this point. I can either take this 1 if its previous is not equal to 1, right? I can take this 1 if its previous is not equal to 1. Initially I can take the first element because it doesn't have any previous element, okay. Now I will be going to this 0. Whether I can take this 0 or I cannot take this 0. I can either take this 0 because the 0's previous is what? 1. So it is alternating in nature. So I can either take it or I don't take it, okay. Again go here. For this 1, what is my previous? It is 0. So I can either take it or I not take it. If I don't take this 0 in my subsequence, then what is my previous value? My previous value will be 1, right? In that case, I cannot take this 1. So this is going to be your combination or backtracking approach. By using this, we can optimize this into dp, and its time complexity will be over n and space complexity will be over 1. Okay, but I am not going to this approach. I am not going to this approach because this approach is very lengthy, but it is mandatory to know about this approach. That's why I am telling you this approach. But as of now, we are going to solve this question using a greedy algorithm. I will be telling you how we are implementing this greedy algorithm. Before that, if you have any doubt in implementing this method, this combination or backtracking method, please comment below. I will be giving you the code, okay, in the comment section. I can give you the code itself in the description, but if you want the explanation for the code and if you want the logic, just comment below. I'll be giving you the separate video for how we are just using this backtracking approach, and then we are just optimizing using dp. Okay, but as of now, for this question, we don't need any of dp. We can go with greedy. I will be telling you why. Because see here it is of only 2 variant. Either it can be 0 or it can be 1. So from this itself, you can know that it is going to be a uniformity concept. Whenever the uniformity concept is true, then we are going for a greedy approach. Okay, fine. So how we are going to solve this? So let me take the example. What is the example? It is 1 0 0 and then 1 0, 1 0 0 and 1 0. Okay. Now I am initially standing here. It is what? It is 1, right? It is the first element. We don't have any previous elements, right? So my resultant will be as of now 1. Okay. Now I will be going here. Now in my previous I will be storing 1 because I have taken this one, right? This one. So my previous will be 1. Now I am at this point. This is what? 0. 0 is not equal to this one, which means it is alternating. So I will be incrementing my resultant to 2, and my previous now becomes 0. Next. So it is 0. What is my previous taken element? It is 0. No, you cannot take it. You cannot take it. Okay. So I'll be going here. Don't take anything in this resultant. Okay. Fine. Now here it is 1. Whether 1 is equal to this 0? No. So I will be incrementing my result to 3 and I will be making this as 1. Okay. Now again go here. So it is 0, and what is my previous element I have taken? It is 1. So increment my resultant and make this as 0. Okay. Again go here. Here there is nothing. That's it. So what is my resultant? Resultant will be 4. Hope you understand this. Why I am going with this greedy approach is, see here there are only 2 possibilities. Either it can be 0 or it can be 1. Okay. So just try to understand this. If there is 1 in front of this, okay, I can either take this 1 or I am going to take this 1. Anyhow, it will be counted as 1 only in my resultant. Can you understand this? Here also, see here are 2 zeros. Anyhow, my count will be have 1 only, because either I can take this 0 or I will be taking this 0. Can you understand this? So because of the 2 possibilities, either 0 or 1, we are going with the greedy approach. Know the difference. This will be very much useful once you are going for the problem solving. If I will be giving you the value from 1 up to 1000 or 10,000, okay, then I am asking you the alternating subsequence, which means no 2 adjacents should be same. Then you are going for the DP or this combination approach. Okay, in this scenario, the uniformity concept will be not there. It will be non-uniform. Okay. Now tell me, what is the time complexity for this greedy approach? It will be O of n, because I am traversing this entirely for only one time. And what is my space complexity? It will be O of 1. So it is basically similar to this DP approach, but in this DP approach, first of all, we will be taking the recursion, then we will be converting into memoization, then we will be converting into tabulation, then again we will be converting it to the space optimization. So these are all the steps that are required in this. It will be time consuming. That's why I'm just telling you this greedy approach instead. If you want to know, just comment below. I will be giving you a separate video for this combination backtracking approach also. Okay, and you can go and watch my moreover DP playlist. Okay, there you can understand how this question is going to be done using this DP. Okay, fine. So let us see the code so that it will be more clear. So here comes, yes. So see here, this is going to be your code, overall code. So initially my array is here. You will be getting the input from the user. Okay, and in Turing, for especially Turing, prefer Python programming. Okay, now result initially 0, previous will be -1. Why? Because there are only two possibilities. It is 1 or 0. You can take any numbers except 1 or 0 because it is not going to be equal to the first element. Okay, so here comes for I in range of len of ARR. Okay, now I'm just checking whether the previous is not equal to the current element. If it is not so, then I'll be just incrementing my result and making the current element as a previous element. Okay, and then I'll be just printing the resultant. You can also do like just take this previous element as ARR of 0. Okay, and take this resultant as 1, and you can traverse from 1 also. This is also correct. This is also correct. Okay, fine. So if I run this, it will be 4. Hope you understand the solution. If you want to know about these kinds of algorithm, just go and search in my YouTube channel, because there are plenty of videos in the YouTube channel to understand the greedy, recursion, dynamic programming, 2-pointer sliding window. If you really like this video and subscribe to my channel, don't skip any videos in this playlist, because all videos will be helpful once you are appearing for the interviews. And see here, this is going to be your recursion code. This is going to be your recursion code. In each and every cells I have wrote this, right? So this is the recursion code, and this is going to be the hash map memorization using hash map, and this is going to be your memorization using array, and this is going to be your tabulation, and this is going to be your space optimization, and this is going to be your greedy approach. I told no. Okay, so understand this clearly. If you don't understand these codes, I will be giving in the description. If you don't understand this code, just comment below. I'll be making the separate video for this. Okay, thank you.